Hey guys, today we're going to talk about atomic orbitals. Remember, Bohr is the organized electron cloud guy. He thought that electrons traveled in planetary orbits around the nucleus, meaning there is only one possible path that those electrons can follow. In addition to that, he thought that the electrons could be in two states. The ground state, which is the lowest energy state, that's where the electrons are when they are normal, when they are relaxed, when they are comfortable, and then the excited state, where there's a higher energy and the electron has moved. So in order for his idea to ring true or to be supported, he has to have two possibilities of where the electrons can be. They can be in the ground state, or the lowest energy, or they can be in a higher energy state, which could be one orbital, two orbitals above them. So we have this electron traveling in the second orbital ring, and when we take energy out, or energy is released, the electron drops back down to its normal or ground state. When energy is put back in, it goes back to the excited state. So right now we're in the ground state, add energy, excited state. Remove energy, back to the ground state, add energy, excited state. If we have energy leaving the system, we are going back down to the ground state. As energy enters the system, the item becomes excited. Okay, so energy going out, we're dropping back down to the ground state. Energy entering, we are becoming excited and bumping up in energy level. So the entire premise, the whole idea here, is that the electrons can move. They have these planetary orbits, but they're able to jump between orbits if there are certain situations that are occurring. One of those situations is applying energy. If we add electricity or run a current through a substance, those electrons are going to jump and switch orbits. So each orbit, or each shell, was given a quantum number. The lowest orbit has a quantum number of 1, the next orbit has a quantum number of 2, etc., etc. As you add energy to the atom, the electron may jump up, like we just saw in that past video. As energy is released, the electron falls back to the N1 level, or the ground state. So the quantum number tells us the relative size of the orbit, and the higher numbers are higher in size. That means that they have a larger atomic radius. So hydrogen and helium only have a quantum number of 1. They are in the first period. Lithium through neon have a quantum number of 2. They are in the second period. Sodium through argon has a quantum number of 3, etc. And we have 7 periods in the periodic table, so we have 7 quantum levels. And the higher the number, the higher the size of the atom. Each orbital is broken down into smaller sublevels. So this kind of looks like stadium seating at a theater. And each sublevel within the quantum level tells us the shape that those electrons are traveling. As the quantum number gets larger, there's more space for the electrons to move. Now when we get to class, I'm going to show you multiple things. First, we're going to watch a video, and they use balloons to show the orbit shapes and how the electrons act and interact with each other. And I'm going to show you some models that I have in class, which actually show us where the electrons are more likely to be. And those models are based on these atomic levels. So the quantum level of 1, this is n equals 1, there is only one sublevel. So there is one shape or one pattern for the electrons to travel through. The next level is quantum number of 2. So this is n equals 2 in this section. And notice there are 2 sublevels. Those 2 sublevels are 2 shapes or 2 areas that those electrons can be. Quantum level of 3, n equals 3. There are 3 sublevels or 3 shapes, and then quantum level of 4. There are 4 sublevels or 4 shapes. So in class, we're going to talk about 3 quantum sublevels specifically: the s orbit, the p orbit, and the d orbit. We are going to mention the f orbit. Since there is such a high energy and there are so many electrons being shared, those tend to have weirder shapes, so they're harder to picture or harder to show. So atomic sublevels, they're broken down into smaller sublevels, and they tell us the shape that the electrons will be traveling. The shape of the atomic orbitals. The s orbital. Those are spherical. So they are completely round and they are 3D. So a round spherical, picture a basketball. The p orbital is a figure 8 or a dumbbell, and they can go along the x-axis, the y-axis, or the z-axis. Picture this one's coming out of the screen at you. So this is a normal x, this is a normal y, and this is a 3D version or a z-axis. And the d orbital is a 4-leaf clover. So it's like two of these dumbbells, but combined into a 4-leaf clover picture. So again, it can be along the x-axis, the y-axis, or the z-axis, and those end up making the orbits look a little bit different. So these three are things we're going to be looking at in class and we're going to be focusing on for the next unit. So when I see you tomorrow or later today, you are going to see a video example as well as looking at orbitals in class. So I'll see you then.